Hello, bachcho. Let's see the question. So the question says, how many total carbons are present in palmitic acid? So since palmitic acid is a type of fatty acid, therefore the key concept in this question is to firstly understand what are fatty acids. So firstly, fatty acids are the building blocks of fats and lipids. Now, fatty acids alone do not form lipids. So fatty acids actually form ester bonds with glycerol molecule, which results in the formation of lipids. Now these fatty acids are actually long chain hydrocarbons. So they have several carbon atoms present in the fatty acid chain. Now these long hydrocarbon chains have a carboxylic acid attached to one of its ends. So this carboxylic acids is what make the fatty acids a particular type of an acid. Now these fatty acids can either be firstly unsaturated fatty acids, or they can be saturated fatty acids. So unsaturated fatty acids have one or more double or triple bonds present in the hydrocarbon chain. But in case of the saturated fatty acids, there are no double or triple bonds present in the hydrocarbon chain. So this is how saturated and unsaturated fatty acids differ from each other. Now, depending upon the number of carbon atoms present in the fatty acids, the different fatty acids are given names. Now, this table depicts the most common fatty acids present in the lipids. Depending upon the number of carbon atoms present in the hydrocarbon chain of the fatty acids, the name is given accordingly to the fatty acid. Therefore, this is the nomenclature of the common types of fatty acids which are commonly found in lipids. So if the number of carbon atoms in the hydrocarbon chain is 12 and there is no double bond present in the hydrocarbon chain, then that acid is known as the lauric acid or laurate. So laurate is a type of fatty acid which has 12 carbon atoms in its hydrocarbon chain and it has no double bonds in it. Similarly, myristate is a fatty acid which has 14 carbon atoms in its hydrocarbon chain and no double bonds in it. Then palmitate or palmitic acid has 16 carbon atoms in its hydrocarbon chain and again it has no double bonds present in it. Stearate has 18 carbon atoms. Arachitate has 20 carbon atoms and palmitoyate has 16 carbon atoms again, similarly as palmitic acid. But the difference here is that it has one double bond present in it. So palmitate and palmitoyate differs from each other in the presence of the number of double bonds in it. Again, oleate has 18 carbon atoms and 1 double bond. Then linoleate has 18 carbon atom and 2 double bonds. And at the last, we have arachidinate, which has 20 carbon atoms and 4 double bonds present in the hydrocarbon chain. So in our question, it was asking that the number of carbon atoms present in palmitic acid. So we can see that the number of carbon atoms present in palmitic acid is 16. Therefore, palmitic acid has 16 carbon atoms present in its hydrocarbon chain. So if we see the options given over here, then option 1, 15 is not the right answer because 15 is not present in any commonly found fatty acid. Then 16 is the right answer, that is option number 2, because we studied in this table that palmitic acid has 16 carbon atoms present in it. Now option 3 is saying 17. Again, 17 is not present in any fatty acid. And 20 is the number of carbon atoms present in arachidonic acid. So again, this is not correct. Therefore, our final answer for this question is option 2, that is 16. That is, there are 16 carbon atoms present in the palmitic acid. Hope you understood it well. Best of luck.